Hi guys, we have a question here that looks like is simple. However, we have to be very careful. And the question is: the nucleus of an atom must contain option A, electron, proton, neutron; option B, proton; option C, neutron; and option D, neutron and proton. Now, like I said before, this question looks easy, but you have to be very careful. If you understand the concept of atomic structure, we all know that an atom is made up of several subparticles. However, we have three of these particles that are fundamental. The three subatomic particles that are fundamental are electron, proton, and neutron. Now, based on the structure of the atom, you agree that there is a central core called the nucleus, and the electron revolve or move around this central core called the nucleus. That means electron move around a central core where majority of the mass of the atom is concentrated. Now, what are the components of the nucleus? The nucleus is made up of proton and neutron. So in that concept, we are not going to pick option A as as the answer. In that concept, we are not going to pick option B. We are not going to pick option C. However, we should be picking option D, which is what? Neutron and proton. If you pick option A, you are wrong. If you pick option D, you are also wrong. So yeah, if you're going to find this interesting, please share and comment as I dive into this question. Let's go there. Recall that I am IY Elvis, popularly called the Evernoic. Now, before I will explain this question, we're going to look at a concept called nuclear symbol. Now, the nuclear symbol of an element usually denotes the composition of the nucleus of the atom. The nuclear symbol of an element is made up of uh, three things. The symbol of the element, let's say X as a symbol of the element. Then we have the atomic mass number of the element, which is represented as A and written as the subscript to the left of the symbol. So I'm going to have, the superscript, not the subscript, rather, the superscript to the left of the symbol. Then we have the proton number, which is represented by the letter Z, now written as the subscript to the left of the symbol. So Z represents the atomic number, while A represents the atomic mass number. Now, A, which is the atomic mass number, is actually the number of proton and neutron. The number of proton and neutron in the nucleus. Now, Z, which represents the atomic number, is actually the number of proton only. So the amount of proton in the nucleus is represented as Z, while the sum of proton and neutron is represented as A. Now, we are going to look at the simplest atom on Earth. Now, the simplest element on Earth is hydrogen. However, we have three different atoms of hydrogen. We have hydrogen 3, 1. We have hydrogen 2, 1. And we have hydrogen 1, 1. Now, to show that They are all atoms of hydrogen. They are different atoms of hydrogen. They all have the same what? Proton number. However, they don't have the same atomic mass number. So in this case, how do we look for neutron number? Neutron number is actually equal to neutron number is equal to A minus Z. So if I minus this from here, I'm going to get the neutron number. Recall that A is the sum of neutron and proton, while Z is just what? Proton. We are going to apply this here so I can answer this question here. Now, what is my, what is my A here? My A is 3. My A here is 2. My A here is 1. Now, what is my Z here? My Z here is 1. My Z here is 1. Then Z here is also 1. Now, can we try to look for neutron N? N is equal to A minus Z, which is 3 minus 1. 3 minus 1 is 2. N here is equal to what? A minus Z. 2 minus 1 is 1. N here is A minus Z. 1 minus 1 is 0. That means we'll all agree to the fact that for a typical atom, the nucleus must contain proton and neutron. But are there exceptions? Yes. For this atom is known as tritium. This atom of hydrogen is known as deuterium. This atom of hydrogen is known as protium. Now, protium or protium. Now, protium here means that this atom only contains proton in its nucleus, no neutron. How many neutrons do we have here? 2. How many neutrons do we have here? 1. How many neutrons do we have here? None. That means, in a nutshell, the nucleus of an atom must contain, is a must. It must contain proton. However, it may not contain neutron. But for a typical atom, a typical atom should contain proton. The nucleus of a typical atom should contain proton and neutron. But is it for all atoms? No, there are exceptions. There's an exception, and the exception is what? This atom of hydrogen. This atom of hydrogen does not have any neutron. That means the only subatomic particle that can be found in the nucleus is what? That must be found in the nucleus is proton. They may not be neutron, they must be what? Proton. So my answer, option A, is wrong. My answer, option B, is wrong. My answer, option D, is wrong. My answer is option C. The nucleus of an atom must it contain electron? No, electron is not found in the nucleus. Electron is seen revolving around the nucleus. Must it contain, this is wrong. Rather, the answer is option B. Sorry for that mistake. The answer is what? Option B. It must contain proton. Must it contain neutron and proton? No, it's not a must. It must not contain neutron, but it must contain proton. I've been able to use this to explain this. If you find this helpful, please subscribe to my channel and comment, then share. Recall, I am IY Elvis, popularly called the Ever Knowledge. Sure you get. Nice one.